Hey Emmanuel, I wanted to record this for you so that you had it for your records. We're going to do this limit, and it's the limit from the left as x goes to -2. So the limit from the left as x goes to -2 of f of x. You want to take values of x for f that are less than -2. That would be this, the square root of -2 minus x, and that is the square root of -2 minus -2, which is 0. The limit as x goes, that's a. The limit as x goes to -2 from the right of f of x would be equal to the limit, this is from the left, as x goes to -2 from the right of, from the right would be values of x bigger, that's x, and that is equal to -2. That would mean that there is no limit. Goes to -2 of f of x. It does not exist, and that is because these two here are not equal. Okay. Continuing, the limit as x goes to 2 from the left of f of x is equal to the limit as x goes to 2 from the left of x, which is 2, and the limit as x goes to 2 from the right of f of x is equal to the limit as x goes to 2 for values of x bigger than 2. That would be x squared minus 4x plus 6. You just plug in the 2. That's 4 minus 8 plus 6, and that is 2. And because they're equal, the limit does exist. So the limit as x goes to 2 of f of x is equal to 2. Okay? And what values of x does this function have a removable discontinuity? Well, you just factor the numerator and denominator. Here you just factor the denominator. This is x plus 1 squared over x plus 1 times x minus 1. And this cancels out to be x plus 1 over x minus 1. And so the removable discontinuity is that x equals -1, because you can remove it here by canceling, but you still have to count the discontinuity. So that one is removable, and the one at 1 is an infinite discontinuity. So the answer is x equals -1. And what values of x does the function have an infinite discontinuity? X plus 2 squared. This is somewhat similar. X squared minus 4. This is equal to x plus 2 squared over x minus 2 times x plus 2. The x plus 2's cancel, and so the infinite discontinuity is where the denominator is 0. If you set the denominator equal to 0 and solve, you get x equals 2. Okay? Here, you want to find where the function is discontinuous. You just want to answer 3 things. And the only places we need to check are -1 and 1. And so you want to check these 3 conditions. F of -1 is defined to be -1 plus 2, which is 1. And then we need the limit as x goes to -1, but that means you just look from the left and from the right. The limit as x goes to -1 from the left is equal to the limit as x, I'm sorry, from the right. The limit as x goes to negative 1 from the right. From the right, it's x squared. I'm sorry, from the right, it's 3 minus x from the right. And that's equal to 3 minus negative 1, and that is 4. The limit as x goes to 1 from the left is equal to the limit as x goes to 1 from the left of, from the left, it would be x squared. I'm sorry, this is negative 1. It would be x plus 2. Okay, wait 1 second. So I was doing, let's go back here. The limit as x goes to negative 1 from the right. Negative 1 from the right is x squared. I was doing 1. So that's x squared, and that is 1. And the limit as x goes to negative 1 from the left is x plus 2. And that is also 1. And so the limit, all three of these are equal. And so the limit is x. So the answer to this is yes. So it's continuous at x equals negative 1. To test 1, f of 1 is 3 minus 1, which is 2. The limit as x goes to 1 from the right of f of x will be equal to the limit as x goes to 1 from the right of 3 minus x, which is also 2. The limit as x goes to 1 from the left of f of x is equal to the limit as x goes to 1 from the left of x squared. And that is 1. And because these two are not equal, then the answer is no. And the answer to the whole question is the function is discontinuous at x equals 1. Hope it helps. I'm going to do the second part in just a second.